Okay, this is the P4 paper from June 2022. It's question number 5, and as you can see by looking at it, this is an integration question, and in particular, integration by substitution. So we know that the integration questions are hard, but what you need to do is to make sure that each different type, by substitution, by partial fractions, by whichever method you have to do, you've got to practice, and this is a perfect example with the substitution ones. So before I get started, I look at it, it says use substitution x equals 2 sine u. There are different ways we can approach this in terms of, do you want to do the limits first? Do you want to substitute your values in? So make it really clear. Have a think about how you're going to display your answer here and get used to writing something down. Let's put the question in. 3x plus 2 over 4 minus x squared to the 3 over 2 dx, of explaining exactly how you're going to be doing it. So I tend to try and sort out limits first. So if I'm looking at this one, I'm going to look at the limits and make it really clear that I've got, if x equals 1, which we have as the top limit, we're going to say x equals 2 sine u, so 1 is equal to 2 sine u, which means sine u is equal to a half, which means u will be equal to 30 degrees, but we're working in radians, so u is going to be equal to pi over 6. Let's do the other one. X equals 0, we'll get 0 is equal to 2 sine u, so I get sine u equals 0, which is going to give me u working out to be equal to 0. Okay, so I've got my two limits. When we're doing a substitution one, especially when we're doing a trig substitution one, but actually with any substitution, it's the dx part that I focus on first. Let's tidy that up. Everything else should be quite easy to work out, but that dx part, if you don't look at it, can often cause you a few issues. So we've got that x is equal to 2 sine u. So dx by du, differential of sine is cos, so is 2 cos u, which means that I'm now going to get dx is equal to 2 cos u du. And I will be replacing that when I come to do all of my substituting in, I will replace the dx with that as well. I think you could just jump straight in and do this now then. So we're going to have that the integral between 1 and 0 of 3x plus 2 over this horrible bit in the brackets, 4 minus x squared to the power 3 over 2 dx is going to be equal to, right, so the limits we've worked out, they're between pi over 6 and 0. And then we've got 3x plus 2, so that's going to be 3 lots of 2 sine u plus 2 over, and then we're going to have 4 minus x squared, so that's 4 minus 2 sine u squared, and that's all to the power of 3 over 2. And then we've got our dx, which is multiplied by 2 cos u du. So even before I go any further, I'm expecting that 2 cos u will probably cancel out with something, or it might turn a cos into a cos squared, which is more useful to be able to use. And the other thing I wanted to say was, look at how neat, I'm not a particularly neat person, but look how neat that writing is, simply in terms of there's a lot of things where you could make a copying error here. So you've got to be really careful as you're going through and doing all this. So let's tidy this up. We're going to say that's pi over 6 and 0 again. The top part is 6 sine u plus 2. And this bottom part, I already know what it's going to be because I can always recognize it, but let's do it slowly. That's 4 minus 4 sine squared u to the power of 3 over 2. But then when we're looking at that, 4 minus 4 sine squared, leave the 2 cos u, du, I'm almost in a rush to get to this bit here. Remember, cos squared x plus sine squared x is equal to 1. I'm doing this slowly. This should be automatic to you. So cos squared x is 1 minus sine squared x. So 4 minus 4 sine squared x, multiplied everything by 4 there, is 4 cos squared x. You shouldn't need to do any of that work there that I've just done. I'm showing it to you, but that should be pretty much an automatic substitution in that I'm going to do now. So we've got, again, just be patient here. So pi over 6 and 0, 6 sine u plus 2 on the top. But on the bottom now then, this is 4 cos squared u to the power of 3 over 2 times by 2 cos u du. And they're just testing at this stage now then that you know what to the power of 3 over 2 means. Well, the half bit of it, that's square root. That's the square root. So the square root of 4 cos squared u is 2 cos u. Yeah, just make that 4. I'm not going to do all this again. I'm just going to jump straight to it. But 4 cos squared u to the half is 2 cos u. So I've got that cubed. I've got that to the power of 3. So if I've got that to the power of 3, I'm actually going to end up, I'm going to do this all in one go here. Hopefully it's not too quick for you. Again, top part doesn't change. But this bottom part now then, the denominator becomes 2 cos u cubed, and I'm going to do 2 cos u cubed quickly as well. It's 8 cos cubed u. Okay? Hopefully that's not too quick, otherwise just rewind the video and have another look at that. Times by 2 cos u du. And actually, I myself am just going to check and make sure I haven't made any copying errors as I'm going through and doing that. Looks okay so far. Really easy to do. And obviously, I want to get all my marks for this one here. So at this stage here, sorry, going back there then, what we can now see is that a cos u and a cos u can cancel. Well, actually, the 2 and the 8 and the 6, we can, no, not the 6, sorry. The 2 and the 8 we can certainly sort out there. So let's put all that back. So what I'm going to do is I'm going to now say pi over 6. Let's take the 2 out of there. So that's going to leave us... No, in fact, let's just be too brave at too quickly. Let's just cancel that with that. So if I cancel that with that, I'm going to have 6 sine u plus 2 all over 4 cos squared u du. So once I've got to that stage now, it then becomes obviously integration using our trig and just being aware of what we've got. Now they're not going to give me something I can't do here. Okay, so if they're not going to give me something I can't do, let's just have a look and see what the terms are that we've got. So the first thing I'm going to do is take the quarter out. And so I say I've got pi over 6, look at the copying error there. 6 sine u plus 2 all over cos squared u du. And I'm now going to split, you might be struggling at this point and think, oh, I'm not sure what to do. This is one of those things which is unusual that we do. We can actually split this up into 2 different fractions now. And I'm pretty confident that when I split it up into these 2 fractions, they'll both be things that I can work with. So I've got 6 sine u over cos squared u plus pi over 6 and 0, 2 over cos squared u du. So now this is knowing your trig identities, being able to change things around, and also knowing what we know the integrals of already. So here I've got quarter integral of between pi over 6 and 0. And again, I don't want to, I don't want to do too many steps here. I'll show you the steps, but I would actually do these a little bit quicker here. I've got 6 sine u over cos u, 1 over cos u, 1 over cos u there, and that's going to be tan u sec u. The 6 is there. But tan x sec x is something that I can integrate straight away. Okay, so when we're doing these, let's put the du's in, put the du in there. That's now a standard integral. I'm okay, I'm happy with that one. Let's do the other part, and 2 over cos squared then is sec squared, isn't it? So quarter pi over 6 naught 2 sec squared u du, and brilliant, I've now got 2 that I know what I'm doing. Let's just tidy up these numbers before we do anything else, because I've got 6 over 4 and I've got 2 over 4 here. So certainly with that one, I'll do that straight away now there. Doesn't matter when you do this, it's whenever you can think about you. Ideally, you could have done it right at the start, but I'm focusing on other things. I want to make sure that I've got these bits right here now. So I know the integral of tan u, or sec u tan u. I know the integral of sec squared. So this has now fallen down to something really quite nice here at this stage. And if it doesn't, you made a mistake. Okay, so just take the 3 over 2 out there. So I've got the integral of sec u tan u there, du, plus a half the integral of sec squared u there, du. Now, by all means, you can do it slightly quicker than this. I'm doing it at the pace of the slowest person that's looking at the video. Hopefully, you might have jumped a couple of these steps here, but certainly we should all reach this stage now and then say, oh, perfect, that is integral of sec u tan u is sec u. The integral of sec squared is tan. We've got a 3 over 2 in front of that one. We've got a half in front of that one. Between pi over 6 and 0. Think, all right, great. So pretty much we're there now, but what we do have to do is to substitute the values in and see what we get. So again, I'm doing this slower than I would if I was going through doing it myself. I'll pretty much just put the values in and see what they come to. But here, 3 over 2 sec pi over 6 plus half tan pi over 6. And then that's all minus exactly the same thing, but with the noughts, isn't it? So 3 over 2 sec naught plus half tan naught. So put those into your calculator. It comes out to be root 3 plus root 3 over 6 minus 3 over 2. And this video is already long enough, so you can work out this a little bit. That's 7 root 3 over 6 minus 3 over 2, which is actually the final answer. What did they say in terms of it? Find the exact value here, yes. So find the exact value here. And with that one, we were trying to get it to that stage there, weren't we, when we were doing the work? Right, so hopefully that will make sense. It's an 8-mark question. Really, that should be one that most of you should be able to do. You know, keep looking at this video and go back and look at other ones that are similar to it so that you begin to get used to the style and the manner of these questions. Okay, hopefully that makes sense.